Okay, let's have a look at this assignment on making relative numbers. You already saw the video where I did Max and Ruby units, and you saw me when I was young and handsome and had a full head of hair dressed as an artillery officer. So with my children, I used to take them to Windsor. And they needed to know how far away Windsor was. Well, how do you teach kilometers to kids? You can't. What my kids did know was the distance to Toronto, and they were fairly familiar with that. Okay, so what we do is we can establish Toronto to be the benchmark. So if I take Toronto and divide it by its own distance, 82.9, okay, we get the number 1. So Toronto is 1 unit away. Then if I take the distance to Windsor and similarly divide it by 82.9, I get 4.14. So when my children asked, how long is it going to take to get to Auntie Jeannie's farm, I could say 4 times further than the trip to see Grandma in Toronto, and give them that. So to do a relative distance, we would simply take all of these and divide by 83. I'm going to round, okay? Ottawa, I've provided you no value. That's up to you to get it. So you have to look up the value for Ottawa. First problem you're going to encounter here is this is going to be a fractional value. It's very common for students to want to do 83 divided by 8.6. I think it's genetic. It has something to do with puberty, because I used to do it all the time too. I just wanted a whole number answer. Get used to seeing it as a fraction. Let's ballpark it. What if you got 8.6 on a test out of 83? Right? 10% of 83 is 8.3. That's just about 10%. So the answer is going to be something like decimal 1. So that would read as Alton is 1/10 the way to Toronto. That's how you have to understand fractions. Then they make sense. In Caledon, at 25 kilometers, what fraction of 83 is that? Well, 3 25s is going to be about 75. So the number you should be getting here is something like a third, or 0.333. Now, what about 83 going into 3,800? Well, I think you can tell. Watch. I'm going to take 83 and I'm going to multiply it by 100. 8,300. If you earn that much money and this guy earned that much money, you've earned about a half of what he is. So I bet you any money you're going to get a number close to 0.5. So what's going to happen is, 0.5. Now you kind of go, well, but sir, you put 2 extra zeros on. Yeah, so my answer here would be 0.5 with 2 more zeros. I bet you it's like 50 times. Now when you go to graph this, Revelstoke I put on there to purposely mess you up. When you go to graph it, the mistake you're going to hit into is there is no way you can graph the numbers from 0.1 to 50 on the same graph. All of these numbers that you receive, you calculate up here, are going to be between 1 and 4. Look at it. Windsor is the second furthest city. Oh, and that'll be Ottawa, all right? So, and Revelstoke is one sticking out. So you really have to fit the numbers. It's going to be like 1 to 4, 1 to 5 here, and you won't know what to do with Revelstoke. And that's what happens with called a scale break. If you deliberately fit Revelstoke in here, like that, then all the other lines are going to become like this. They're just going to be so tiny you won't even see them. If you decide to shrink Revelstoke so it fits, so the other ones fit, then Revelstoke is going to shoot off the page. You're going to need a roll of toilet paper to write it down. So to fit in the numbers, you're going to set your graph up from like 1 to 5, and you will have columns for all the other cities here. And then for the Revelstoke one, you're going to go up, you decoratively break the bar, you go like this, and you write down what the number was on the top. And in terms of how to set up the scale, you've got 0, 1, 2, 3, 4, 5, 6. Oh, I can't. I got the wrong glasses with me today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I would just go up to the 20, and I think you'll realize what numbers you should jump by to fit all the cities on here but Revelstoke. If you can do this with cities, you can do it with the planets. On this side, we have the planetary distances. These are in multiples of 1 million. So you would read Earth is 150 million kilometers from the sun. We're going to turn Earth into the equivalent of Toronto on the last page. We are going to divide the distance Earth is from the sun by itself. And we get that the Earth is 1 unit away from the sun. And we nickname that 1 astronomical unit. I used to use Max and Ruby units for time. I use Toronto units for distance. This will be this will be astronomical units. Now, what does this allow us to do? Well, by the time we divide everything else here by 150, okay, let's take Saturn. If I divide by 150, I'm going to get a number extremely close to 10. So I'm just going to round it to 10 astronomical units here. This said, Saturn is 10 times farther away from the sun than Earth is. Now, what numbers would you rather look at? Remember, these are hiding 6 zeros. If you don't like it in this version, you'd have to write 1, 4, 2, 7, 1, 2, 3, 4, 5, 6, and compare it to this number up here, which would be 1, 5, 0, 1, 2, 3, 4, 5, 6. When you look at these two numbers visually, it's very hard to compare them. By setting them up this way, we can see the ratio of their behavior. And when you get out to like Pluto, which has sort of been fired, we can again go divide by 150, and you're going to get a number. And then it actually caused guys like Kepler, when they simplified these numbers like this as ratios, they spotted mathematical patterns that were not obvious here. What happens when you get to Alpha Centauri? This one has an exponent on it. It is not the same number as up there. Okay? So you have to use the full number on your calculator to do that one before you can do the math, and you will get a ghastly large number here. So that's how to do the relative numbers.